Okay. Is it good? Okay. Okay, great. It's so good to see so many people here. And well, as previous speaker said, so my talk, well, lots of subject has been discussed. Also, what I'm going to talk about too. So I want to start my motivation with a tribute to Siemens, as we all know. So they have great machines which can do lots of things for us. They can do poses. They can do objects. They can do segmentation. So this is a very good tool which we all know about nowadays. So these tools can do lots of things, almost anything. So this is example of they are doing anything. This is a network which is trained with random labels with some constraints, and then still it predicts it's a very good tool for pre-training. Probably not as good as kinetics, but still very good. Why I'm talking about this, because if we have this great tool, there are, well, of course there is lots of and there've been very great talks today how to make these tools even better. But there's also important question: what are the actually tasks which we are feeding these tools? Because if they can learn anything, then what do we actually want from them? And so the question we've been looking for a while is in video actions, and so we can of course populate and come up with lots of different action labels, but what are the action labels? What are they really meaningful? So here's an example of open. You can all call it open. Is it really what we want? The granularity is not very clear. Then so there is ambiguity in terms of labels also mentioned today, like if you give context, so you may not just call it running, but something else. But even so, labels are not the only problem. So even if you somehow solve the labels, then it's still not so. Like these are typical things which we can do very good. If we know all the labels, what happens for object actions, will it bring us to understanding what will happen if one shakes the tree? Of course, you can collect thousands of examples of this. Okay, maybe eventually but this is a compositional task. So how to train this to do prediction well for such a task? It's currently completely unclear. So we've been thinking about how to how to go on with the video understanding, and should we just multiply the number of actions? Should we look at objects, interactions? So all these are interesting things. So instead, one can try to maybe not go movies or any open domains, but look into more specific domains. And specific domains we are interested in are here are instructional videos. Okay, I'm going to talk about this later. So more task-specific action understanding. So it's not about how you live your life, what you can see in movies, but more into how do I perform a task. And so the applications for this could be automatic visual guidance. So if you have a HoloLens or some other device which can help you to achieve some tasks which you don't know about, we can do lots of things. That's why people watch and post instructional videos on the web. So if we can learn do many things, and eventually robotics. So if we can learn robotics, how to do things. So okay, this is almost the end of the motivation. So what we want to set up the problem, instead of trying to say or ask Mechanical Turkers or somebody else what are the actions, what are the splits of the actions. So we want to pose the problem in the way of what are the important actions to come from this state to this state. So you have two states of the world, okay, and well, eventually if you want to solve the study, if you want either your person who is doing this or a robot who is learning from this video to assemble this furniture. So the important question is, what are the maybe primitives which it should learn in terms of actions which will bring this state of the world to this state? Yeah. So this is our motivation. Okay, we are not there yet at all, but I think this is one interesting way to pose the problem. To help us on this way, there is a great resource of instructional videos, which have been mentioned already today many times. So you probably all know this. So there are lots of them on the internet. And we started looking at this a bit earlier, so I'll talk about a few works which we've been doing in this domain. So what is instructional video? It's a video where people usually show how to do things for other people, and they also talk about this. So it has the transcription. YouTube transcription has got very well over the last years. We monitored it, so 3-4 years ago it was not so good. Now it's almost not perfect, but very good. So okay, so you can find lots of these videos. So we've looked at this from different perspectives. So first question of what we try to ask is, so given if you have one instructional video, this is hard to understand, but if you have many of them, you can assume several things. For example, that important steps, actions, they should repeat over time, and they should be consistent over the videos. Okay, so it becomes a clustering problem. So we can, and because we have video and text, so this is a nice setup where we can do joint clustering, basically trying to find the clusters of text which correspond to an action, clusters of video corresponding to an action, and then okay, and so this way, so this is already a few years back, so you probably seen some of this work. So these are the typical actions which we find when we take the say hundreds of videos for changing car tire. So we will find something like loosen nuts, jack car, remove wheel. Okay, so it's not this is not robotics yet, so it's not actually clear that these actions are key actions for performing these tasks, but they are these are actions which repeat over and over again, so we assume that they should be important. So another work in this domain was just analyzing another hypothesis, still in the scope of instructional videos. Actions are often there to modify the state of the world, either like to unpack the IKEA furniture and build the whole thing, but even on a smaller scale. So if you do here filling the cup, or so here's a state of the cup before the action, this is the actual action, this is the state of the cup after the action, and so the same with the car wheel. So the wheel is first not on the car, then somebody is mounting the wheel, and then it's on the car, or with opening the fridge. So there is a correlation between state of objects and actions, and actually they both help each other. And as we go further, so that's work was presented to CPR this year. So if you go further and increase the size of the data set of instruction video, then you can start analyzing more things, and because the actions, they will be, or the steps of the instruction videos, they will be shared between different tasks. So here we are still modeling the goal of extracting the main steps of the video, but here we try to share the steps between the tasks, and also have a component model where we model explicitly things like pouring, mixture, so which will be shared between different actions and between different tasks as well. Sorry, I'm going very quickly about this. So for this, we have a bigger data set for instructional videos, because if you want to analyze sharing, you need to, like 5 tasks would not be enough. You need to, so here the scale is about 80 different tasks. And what we observe that indeed, if we don't share, we get some performance. If we start sharing, we get performance. And then also this is just gathering more and more, not just videos, but gathering more tasks which are related. They help the performance. And we can also do the things which we have not seen before, because this is a shared model. So we learned what is the strawberry, what is the cake from somewhere, from what is add from some other tasks, and then the more tasks we see, the performance goes up. Okay, so well, this work is going to appear at ICV. So it has been mostly motivated by the data. So with the previous work, we've seen more and more instructional videos. Probably the instructional videos also increase on the internet because it's a popular domain, and there are sites like WikiHow, which actually that's not about instructional videos, but they explain how to do things. They have a structured, even hierarchical way of organizing the things which you can do in your life, like how you meet your husband or future wife, which we are not interested here. But so we had a manual pass over the tasks on the task level. So they have, say, I don't know, maybe they have 40,000 tasks on this side. So we went over, not we, but we hired some people who went over the tasks and just said, okay, this is visually interesting. This has some visual grounding, not. And okay, came up with the 23,000 tasks, and then just downloaded the videos from YouTube for these tasks. Ended up with 1.3 million videos after some simple filtering, and then just took the pieces of video which had some text with them associated, right? So these videos might be long, so then the clips are short. And so ended up with 130 million clips. So, why this? So on this, and by the way, so this is one or 1.5 student projects, and we are still academic lab, so it's possible to do large scale, even on the scale of one student. Yes. So previously, this. So we are looking into. Andrew has mentioned this. So we are looking into video retrieval task here. So where you have text and video, you want to have a common embedding, right? So this is the setup where we have lots of video, we have lots of text, which come together from the instructional videos. We learn this joint embedding. So this is a very standard thing. This is not much new here. So what's new is really the amount of data, and so for the task of video retrieval, there've been previously some data sets which are manually annotated. Well, they're either manually annotated or manually curated, so they're verified to be correct. So this data set is 1,000 times larger, but it's not manually curated because it's hard to do it on this level. Actually, consistent with what Hilde just said, so we also found that 50%, about 50% is the noise in it. Still, so what you can do with it? So you train, so in this case, we don't even fine-tune any of these embeddings because that's for academic lab, that was too much. That's why the student is now in DeepMind. So, and but still, so what you can do without fine-tuning by taking the great features from train on kinetics. So you can basically you train the embedding, and you take some standard text embedding. You take features, you train embeddings, and then, well, that's what you get. So if you do text-based video retrieval. So here I'm showing examples which are becoming more and more complicated or more fine-grained. So you have cut paper. So here's an example of cut paper in circle. Okay, so the demo is online actually, so you can go there and try to search this data set yourself. It works. So here's another similar examples. So it shows two things. One thing, it shows that the data set is large. That's why you can actually acquire something very specific. So if you would acquire random specific things in a small data set, you will not be successful just because the data set is too small, and it's very unlikely that you will, it's there at all. But also the fact that it is able to find things which are quite fine-grained is also showing something about the method. Or actually the training data, because we are not doing something special about the method. So here are some numbers. Actually, yes, does it help to grow the data even more? This is log scale. On log scale, it's still linear. So if you, we are at this scale, well, going further, because it's all unsupervised, so we believe it's possible. So the green curve is on our data. So train on our data and then test it on some validation set. So these curves are video retrieval on the previous data sets, which are smaller. Okay, and so here I'm going to show a few interesting insights in numbers. So here UCook2 data set is very good. So it's about cooking. still it is about 1,000 times smaller than ours. Yeah, so we have a baseline, just training the feature on the UCOOK data set. Almost done. So right, so okay, so our baseline is doing comparable if we train on this data, but if we train on our data without any of the labeled data from UCOOK2, so we get better performance. And then if we then if we combine, we get even better. So there is another data set. This is video. This is more general YouTube videos. So if we train on our data set, the numbers do drop because the domains are different. But then if you take a bit of training data from the original domain, so it gets better. Okay, so so there are instructional videos. I think this is a great domain. If you want to address this application, there are still a few questions. For example, so she's doing if we just tell her to put this thing here somehow, so maybe she's holding it in a wrong way, wrong angle. So it's not just about labeling. So we're also looking at more fine grain. So we had a paper on reconstructing hands and objects, where we're really trying to understand what's the precise, how people precisely hold the objects or manipulate the objects. And then this is my last slide. So importantly is that instructional videos, again, are great because they show lots of variability. There are many of them. They show different, they sample the world very well. However, they usually show good things. They don't show failures, because people would not put the failures online. So if you want to go through, well, if you want to train something for real robots, we know we need failures to learn from. We need negative examples. But robots actually, if starting working in robots, so we realize that robots only do mistakes. So that's, it seems to be a good combination. So if we try to get advantage from instructional videos and doing robotics at the same time, so this is my belief that the future for vision, at least one future for vision, I think, is robotics. And this is all I have to say. Thanks.